Stratified sampling is the last strategy that this course describes. Stratified sampling uses random selection within predefined groups. The sampling frame is divided, or stratified, into homogeneous groups with similar characteristics, such as region, gender, or intervention type. Then, a sample is drawn randomly from each of these groups, also referred to as a strata. The sample size for each group can be proportionate or disproportionate to the relative size of the group. With proportionate stratified sampling, the sample size of each stratum will be equal to the proportion of the subgroup in the population. If the population is 20% women, for example, women will be 20% of the representation in the sample. With disproportionate stratified sampling, the sample size of each stratum will not be proportionate to the size of the subgroup in the population. Disproportionate sampling is used to give larger than proportionate sample sizes to smaller subgroups to enable analysis of that subgroup. Stratified sampling is useful because it ensures that the sample you draw will have enough data for sub-analyses of characteristics that have low prevalence in the broader population. For example, if 80% of your sampling frame is in region A, and individuals are selected randomly using one of the previous other sampling strategies, you might only have a few responses from regions B and C, and therefore not enough data for a meaningful regional disaggregation. Using stratified sampling helps us to avoid this issue. One disadvantage of stratified sampling is that it's more complex than the other strategies and requires using sampling weights when analyzing your data. Stratified sampling also requires us to consider how to stratify a population, which can create more risk for bias. Additionally, stratified sampling typically requires a larger sample size compared to simple random sampling. In terms of when to use it, there are a couple scenarios where stratified sampling is most appropriate. One instance is when the outcome you're interested in measuring is strongly correlated with particular characteristics. Let's say we're researching school attendance rates, and the program used different types of interventions to encourage attendance. In this scenario, the program might stratify by the intervention type, separating the sampling frame into different groups based on the type of intervention received. Another instance where stratified sampling is typically used is to ensure that groups that might be underrepresented in your population are represented in data collection and analysis. For example, if your sampling frame has few women, but you want to make sure their presence is accounted for in data collection, you might use oversampling to gather a disproportionate number of women because they are not likely to be selected using random sampling. This method ensures that the sample will have enough data to have meaningful gender disaggregation. In this instance, the sampling frame would be divided into women and men, and a sample would be drawn randomly from each of those groups. Stratified sampling can be useful when the researcher knows the population and can determine a stratification that makes sense for the questions that the survey is seeking to address. However, USAID-funded partners working on emergency programs should note that BHA discourages the use of stratified sampling due to its complexity in weighting and data analysis. As you'll see in the next module, using systematic random sampling with your sampling units, sorted by the strata of interest, will achieve the same result as proportionate stratified sampling. Both methods will produce a proportionate sample equal to the distribution of the population. For this reason, proportionate stratified sampling is not the best reason for doing stratified sampling. Finally, here's a graphic presentation of stratified sampling, both proportionate and disproportionate.